Hello physics students, welcome to class today. Today we're going to be delving into Newton's first law, and to start us off today I'm going to do a couple demonstrations with the help of Physics Pony. And we'll do another little demonstration. So first off, Physics Pony is not being safe, and Physics Pony is driving an automobile without their seatbelt. Oh my gosh, I know. Not safe at all. And Physics Pony is driving along the highway at high speed and all of a sudden encounters a very stationary object. What is going to happen to Physics Pony? Well, let's take a look and find out. Uh-oh. Physics Pony went flying. That's not a good day for Physics Pony. Not a good day for the car. Wear your seatbelt. Alright, second demonstration. This is my second take at this video because I messed up this demonstration 3 times in a row. And my mentor when I first started teaching physics always told me, if your demonstrations work every time, it's time to retire. So, this is now the 4th take for this demonstration. So, I have a quarter, an index card, and a beaker. Put the index card on the beaker, put the quarter on the beaker, or on the index card, and I want to make the quarter fall straight down. So we're going to flick the card, and it works. So the quarter drops straight down. Well, let's take another look at this, and what if I were to go ahead and, oh gosh. What if I were to go ahead and just draw this card slowly out from underneath the quarter? Let's take a look at that. The quarter comes right with the card. Okay, so my goal is that you understand why these events happen by the end of class today. We're going to describe Newton's first law, and hopefully you will have some real world examples to come away from this lesson with. So, definition of Newton's first law. Many of you have probably heard of this law before, but an object will stay at rest or in motion with the same velocity unless acted upon by an unbalanced force. Okay, so Let's unpack that a little bit. First off, what is a force? Well, a force, I like to call just a push or pull. So anytime an object is pushed or pulled, we say that a force is being applied. And it doesn't have to be with a hand, it could be with magnets, it could be with a string. We'll go into the types of forces in a future lesson. But for right now, simple definition of force is a push or pull. And unbalanced. Well, what does unbalanced mean? If you said one side bigger than the other, you'd be absolutely correct. Unbalanced just means more on one side or the other. And we'll get into, I have a whole lesson coming in a future video on unbalanced forces and how to calculate the unbalanced force of acting upon an object. So, but right now all you need to know that an unbalanced force is more force on one side or the other side. Or if we have an object that a push or a pull is bigger on one side than the other. So, I also have this wonderful beaker. Let's pretend this beaker is a cup of coffee in the morning, and I'm driving along the road, and all of a sudden a deer jumps out in front of my car, and I slam on the brakes, and I'm moving. What do we think is going to happen to my coffee? Well, my coffee's going to go flying if I don't have a lid, right? If all of a sudden I'm moving, and I just stop, coffee spills out. Same thing if I'm sitting at a stoplight and I'm in my new Mustang. I don't have a Mustang, by the way. And I look and there's someone next to me and I'm like, oh yeah, let's race and go fast. And I'm about to sip my coffee and I accelerate fast. What's gonna happen? If If I speed up, all the water's gonna come right out at me and my coffee is going to spill all over me. And that would be sad, especially today because I'm in a white shirt. I have a coffee stain. Bad day, bad day. So why does the water spill out of the cup? Well, because we are changing our state of motion. That I was at rest and now I'm accelerating and my state of motion is changing. That water has a tendency to want to stay at rest or stay where it was. This water, to start right now, is happy being in here. It's in its happy place. It's content just sitting, filling this beaker. However, when I start going, my hand is touching this, when my body is touching the car, and when I start to move, the water is not contained in this vessel. It's free to move around. And so when I start to go, the water wants to stay where it is. And so the water wants to stay, and eventually I move into the water space and the water starts to come onto me. Bad day for Mr. Magaluk. I'm not sure if that's a good day or a bad day for the water. But, so whenever an object's state of motion changes, water spills whenever the object's, whenever its state of motion is changing. If I start to, let's say, run in a circle, the water will spill out. Woo! Start to spill out of the cup, right? And that's because it wants to stay where it is, and now I'm moving it into motion, and then I'm stopping all of a sudden. Here, let's try. I'm stopping all of a sudden, and the water just wanted to keep going, and so it would go flying. Okay? What are some, well, if you were all in class with me, I would ask you, what are some other examples, and we'll probably talk about this in class, but some other examples of this is, how many of you have probably had ketchup or mustard on your hot dog or hamburger or veggie burger, and let's say the ketchup, there's just a little bit left in there. What do we do to get that last little bit of ketchup? Well, we slam it on our hand. Well, this is applying Newton's first law, that the ketchup, we speed it up, and then when we stop the bottle all of a sudden, the ketchup wants to keep moving because it's in a state of movement, and then the bottle stops, and so the ketchup keeps moving towards the front of the bottle. This is the same for a shampoo bottle or conditioner bottle where you're to the last little bit. That's Newton's first law in action. Let's see, what else? Well, yeah, let's say if we're, riding on public transportation. Going to or from the airport, standing in one of those shuttle buses, you're hanging on, you're standing. Well, what happens when the bus starts moving all of a sudden? Our bodies want to kind of lean backwards, right? It's because our bodies were at rest and the bus now starts to move. Well, our bodies want to stay at rest. They're content being where they are. And the bus starts moving, and so we appear to move backwards because the bus is moving forwards and our bodies want to stay in the same spot. Same thing when all of a sudden we're moving on the public transportation and the public transportation stops, our bodies want to keep moving forward because we are in a state of motion. The bus is stopping, however, our bodies want to keep moving. And so we appear to move towards the front of the bus because the bus is actually stopping. So going back to these demonstrations, and just to quickly talk about them, hopefully you all, well actually, I want you to try and explain both of these demonstrations. So pause the video, take a minute, think about these demonstrations and why they work. So go ahead and pause the video and think about it. Alright, so for the coin demonstration, this coin is at rest, and it wants to stay at rest. The reason that when I flick the index card versus when I pull it is when I flick it, it happens so quickly, friction does not have enough time to move the coin, and so the coin drops straight down. However, when I just simply pull the index card, the coin is being pulled by friction, causing it to move. Physics Pony, driving along. Why does Physics Pony go flying? Well, Physics Pony is already moving at a high speed, and then when the car stops, Physics Pony without their seatbelt wants to continue moving at the speed they were moving, and therefore goes flying, which is a sad day for Physics Pony, and that's why we all wear our seatbelts. Hopefully Newton's first law makes a little bit more sense. We are now talking about forces, and the reason we've been talking about motion, acceleration, and now forces are the reason that motion and acceleration happen. And we'll be delving into that a little bit more. In a coming lesson, we will be talking about balanced versus unbalanced forces, and the different types of forces. So look forward to that. Thank you all for watching. We'll catch you in the next video.